Hello class 7 students, welcome everyone. So today we are going to discuss about electromagnet. Our next topic will be electromagnet in the chapter electric current and its effects. Okay. So before discussing about electromagnet, let us first revise the previous topic which is given in the previous video, that is magnetic effect of electric current. What is magnetic effect of electric current again? If I ask you, what is it? When electric current passes through a wire, yes, when electric current passes through a wire, then what will happen? The current carrying wire behaves like a magnet. Okay, the current carrying wire behaves like a magnet. So in the activity 14.5, yes, in the activity 14.5, we have discussed that a current carrying wire was able to deflect a compass needle. Yes or no? A current carrying wire was able to deflect a compass needle. So it was concluded that the electric current flowing in a wire gives rise to a magnetic field around it. It will give rise to what? The electric current flowing through these wires will give rise to what? Magnetic field. That is why it is showing magnetic effect. Okay, the current carrying wire produces magnetic field around it. That is why this current carrying wire was able to deflect the compass needle, and the effect which is shown by this current carrying wire is the magnetic effect of electric current. Clear? So this magnetic effect was first discovered by who? It was first discovered by a scientist named Hans Christian Ørsted. Okay, Hans Christian Ørsted. Clear? Okay, so let's begin with the topic electromagnet. Right? Okay. So first of all, electromagnet. You see, there are two words involved in this: electro and magnet. So what is an electromagnet? The magnet which is made by using electric current is called an electromagnet. Clear? The magnet which is made by using electric current is called an electromagnet. Okay. An electric current can be used to make magnets. So the magnet which is made by using electric current is called electromagnet. Okay. And this electromagnet works on the magnetic effect of current. Okay, electromagnet works on the magnetic effect of current. So here is the figure 14.19, which shows an electromagnet. So what an electromagnet consists of? An electromagnet consists of a long coil of insulated copper wire, okay, wound around an iron rod. That means, suppose if you take an iron nail also, no? If you want to take an iron nail also, which is of about 6 to 10 centimeter long, 6 to 10 centimeter long, you have to wound around say a copper wire, yes, an insulated copper wire over it. You have to wound around what? An insulated copper wire, just like this, which is shown over here. Okay, you have to wound around an insulated copper wire around an iron nail, or say an iron rod. Okay, so when the two ends of the coil are connected to a cell, this one of the end is connected to the cell via the switch. Okay, and the other end of the coil is connected to the other terminal of the cell. Okay, one of the end is connected to the negative terminal of the cell through a switch, and the other end of the coil is connected to the positive terminal of the cell. Clear? So when the two ends of the coil are connected to a cell, then current passes through the coil, produces a magnetic effect. Okay, when the switch is on, then current will pass. Obviously, the current will pass. So this current which is passing through the coil, the setup will behave like a magnet. Okay, it produces magnetic field and it produces magnetic effect. So when the two ends of the coil are connected to a cell, then current passes through the coil. Current passes through this coil, produces what? Magnetic effect. So this magnetic effect magnetizes the iron rod. Due to this magnetic effect, it will magnetize. It will what? Magnetize this iron rod will behave like a magnet. It will behave like a magnet. So it will magnetize the iron rod. The current carrying wire, which is the current which is flowing through this coil, through this wire, it will magnetize the iron rod. So the iron rod becomes an electromagnet. Okay, so this iron rod will become what? An electromagnet. So one more thing you have to remember, that this iron rod, this iron nail, or say the iron rod, will get magnetized when the switch is on. Okay, when the switch is on, then it will get magnetized and it will attract the metallic things towards it. If any metallic things are kept near to it, then it will attract those things. Okay, it will get magnetized and it will start behaving like a magnet. So what does a magnet do? Magnet attracts the things made up of metal towards it, right? So it will also attract the things which is made up of metal towards it. Okay, if you place small iron nails over here, just like this, some iron pins are kept near to it, then this iron rod or the iron nail will attract the iron nails towards it. Why? Because it will behave like a magnet, so it will attract. Clear? But if we switch off, if this switch is kept off, if the switch is kept off, then the current in the coil, what? The current will flow? No, the current will not flow. If we switch off the circuit, then the current will not flow, obviously. So all the magnetism of the iron rod disappears and it will no longer behave like a magnet. Okay, it will behave like a magnet only when it is kept on. When the switch is kept on, then it will behave like a magnet, so it will attract the iron pieces towards it, the metallic pieces towards it. But if it is kept off, then the current will not flow. That means it will not behave like a magnet at the time. Clear? Now let us see what is given in your book, say through an activity 14.6. Take around 75 centimeter long piece of insulated flexible wire and an iron nail, say about 6 to 10 centimeter long. Clear? You have to take an insulated copper wire first of all. Okay, insulated means it must have plastic covering over it. Okay, plastic or cloth covered with plastic or cloth covered or enameled. So it must be insulated, the wire must be insulated. And you have to take an iron nail also, which is 6 to 10 centimeter long. Okay, wind the wire tightly around the nail in the form of a coil, just like this, the setup which is shown over here in the figure. You have to wind the copper wire around the iron nail. Okay, just like this. Clear? Connect the free ends of the wire to the terminals of a cell through a switch as shown in figure 14.19. Okay, you have to connect the free ends of the insulated copper wire to the two terminals of the cells through a switch over here, through a switch. You see, as you can see over here, the bottom free end is connected to the positive terminal of the cell and the upper free end is connected to the negative terminal of the cell through a switch. Yes. Place some pins on or near the end of the nail. If you place some pins near to the iron piece or iron nail, what will happen? What will happen? Initially, there will be no attraction. Initially, there will be no attraction because the switch is off. First of all, the switch is off, right? So if the switch is off, then no current will flow through the wire. That means the iron rod or the iron nail is not getting magnetized. But when the switch is on, now switch on the current, what happens? If you switch on the current, current will flow. Okay, current will flow through the circuit. Yes or no? If you switch it on, current will flow through the circuit. Yes. Then this iron nail will get magnetized, it will behave like a magnet, and it will start attracting the iron pins over it. Okay, it will start attracting. Okay, so do the pins cling to the tip of the nail? Yes. Switch off the current. Are the pins still clinging to the end of the nail? No. Okay, so when the switch is on, electric current flowing in the copper coil or copper wire has turned the iron nails into an electromagnet. Are you getting it? And when the switch is off, the current through the coil wire will not flow. So, by switching off the current through the coil, the pins will get detached from the iron nails. So, they no longer cling to the iron nail. Are you getting it? Okay, so this means that when the current is stopped from flowing in the coil of the wire, the iron nail no longer remains a magnet. That means the iron nail loses its magnetism. This iron nail will lose its magnetism when the switch is off. Are you getting it? So the coil in the above activity behaves like a magnet when electric current flows through it. And when the electric current is switched off, the coil generally loses its magnetism. Clear? So such coils are called what? Electromagnets. Okay? You see, you can make electromagnets in a very large scale. Okay? And it can be made strong also. Okay? When a huge amount of current will be flown through it. When a huge amount of current will be flown through the same setup, then the electromagnet can be made very strong and it can lift very heavy loads. It will behave like a magnet, right? So it can lift heavy metallic loads. Are you getting it? Okay. You see, the electromagnets are also used to separate magnetic materials from the junk. So doctors use tiny electromagnets to take out small pieces of magnetic material that may have accidentally fallen in the eye. Many toys are also have electromagnets inside them. Okay, clear? One of the device which works on the magnetic effect of electric current, which has electromagnet in it, is your electric bell. Okay, which we'll discuss in the next video. Clear? So that's all for today. I think you have understood about electromagnet. Okay, so we'll continue the chapter in the next video. Okay, so that's all for today. Thank you and have a nice day.